All right, year 10s. Welcome to part 2 of sketching parabolas using turning point form. So, looking at this example, again, we're going to write your general equation for turning point form. So, a outside of x minus h squared plus k. We're going to find the turning point, its nature, our y and x intercepts before we sketch. So the first thing I'm going to do is I'm going to observe that a is minus 2. And that tells me that this is going to be a maximum because a is negative. My h value, in this case we can see that minus h is equal to positive 3. So I can say minus h is equal to 3, in which case h is equal to minus 3. Looking for my k value, I can see that positive k is equal to positive 6, so therefore k is equal to 6. From this information here, h and k, I can find my turning point. So TP is equal to minus 3, 6, and it is a maximum as a is negative. That leaves me with my x and y intercepts. My y-intercept occurs when x is equal to 0. So y is equal to negative 2 outside of 0 plus 3 squared plus 6. Y is equal to negative 2 outside of 3 squared plus 6. Y is equal to negative 2 outside of 9 plus 6, which is negative 18 plus 6, which is negative 12. So my y-intercept is 0 minus 12. My x-intercepts occur when I let y equal to 0, such that 0 is equal to minus 2 outside of x plus 3 all squared plus 6. Now, my first step here has to be to divide by 2 to remove that coefficient of my x plus 3 squared. So, when I divide by minus 2, I'll just do that in different colors so you can see. Divide by minus 2 to both sides. Then 0 divided by minus 2 is 0. This term here, minus 2 outside of x plus 3 squared, divided by minus 2, just becomes x plus 3 squared. And my positive 6, when divided by minus 2, becomes minus 3. Now this is beneficial, as if it was a positive, I wouldn't be able to use my dots. So using difference of perfect squares, we're going to separate this into two binomial factors. We have x plus 3 plus the square root of 3, x plus 3 minus the square root of 3. From here, I can find my x-intercepts, either x plus 3 plus root 3 is equal to 0, in which case x is equal to minus 3 minus root 3, or x plus 3 minus root 3 is equal to 0, in which case x is equal to minus 3 plus root 3. Remembering that the square root of 3 is 1 point something. So my two x-intercepts are minus 3 plus root 3, 0, and 3 plus root 3, 0. Now I have all the points that I need to sketch my graph. So my turning point is minus 3, 6. I go to minus 3, I go to 6, that's it there, minus 3, 6. My y-intercept is negative 12. Do apologize, that is minus 3 on my other x-intercept. So I have minus 3 plus or minus the square root of 3. Now the square root of 3 is 1 point, about 1.3, 1.5. Give me 1 second. I'll just put it into a calculator now. $1.7. So 1.73, the 2 decimal places. If I have minus 3 and I subtract an additional 1.73, it'll take me to negative 4.73, which is about here. So that is my minus 3 minus the square root of 3, 0. And if I take negative 3 and I add 1.3 or 1.7, that's going to take me down to about 1.3, which is about here. So that is minus 3 plus the root of 3. So finally, all that is left to do is to sketch my parabola. I'm going to try and get all points on the same screen. There we go. All right, beautiful. So starting with my x-intercept, it's going to come up, curve at the turning point, come back down through my y-intercept and continue down. Now, unless there's a domain restriction, your parabola should continue to the edge of the graph. And that is how you sketch quadratics using turning point form. Good luck.